Recent advances in real-time fur rendering have enabled the development of more realistic furry characters. In this sketch, we outline a number of advances to the shell and fin-based fur rendering technique by Langell et al. Using the pixel and vertex shader capabilities of modern 3D hardware. These extensions are designed to make the fur more user-customizable at a more fine-grained level. This includes both static author-time customization and on-the-fly dynamic customization to implement special effects or physics on the fur. Our extensions to previous techniques include shell and fin extrusion using vertex shading hardware, per-pixel anisotropic lighting on fins and shells, hair color sourcing, hair density control, and bitmap generation. Vertex shaders allow for more flexibility in fur rendering by performing the shell and fin extrusion in hardware. We can scale the height of the fur by merely setting a vertex shader constant which can be varied over time. A possible application of this is to have characters in a video game have shrinking or growing hair during the course of the game. One interesting property of stochastically generated fur is the distribution of hair directions throughout the texture. Due to the changing directions of curly hairs, it is no longer sufficient to derive hair direction for lighting from only the albedo texture. When rendering the fur, the per-pixel direction can be used as a direction of anisotropy for Heidrich's real-time anisotropic lighting technique implemented at the pixel level. This allows individual hairs to capture diffuse and specular lighting, breaking up the homogeneity of the fur and producing a more realistic rendering. Here we show the tangent space direction of anisotropy map, which is used to implement per-pixel anisotropic lighting. Here we show only the shells. And here only the fins. Another technique that we have used in all of the examples so far is applying an albedo texture that produces color variations for different regions of the fur. The alpha channel of this texture can also be used as an opacity value to produce bald spots as we have seen on the torus. However, when the fur texture contains very wavy or slanted fur, each hair will change color over its length due to the fact that the texture coordinate used to fetch from the albedo texture is directly tied to the hair's position as projected down onto the surface. A better approach is to fetch from the same texel from the albedo map over the entire length of the hair. This way, when there are sharp edges in the albedo map, the hairs from both sides of the edge will intermingle, giving a more realistic appearance. Another parameter that can be specified over the surface of the object using an albedo map is hair density. In order to do this, an additional texture channel is generated in parallel with the other fur texture channels. In this channel is a thinning value from 0 to 1 which specifies the percentage of the fur texture left to be generated. The first hair generated gets a value of 1, and the last hair generated gets a value of 0. In the pixel shader, a pixel is only rendered if its thinning value is less than or equal to the albedo map's density value. This density value causes a percentage of the hairs to not be drawn, thus thinning the fur. This quadrilateral is drawn with solid blue fur whose density is controlled with this mechanism. Simply downsampling the color-encoded direction and offset textures used on the fins and shells causes incorrect results due to the unfilled pixels in the texture. To solve this, we replace each unfilled pixel in the texture with a weighted average of the filled pixels within a small kernel radius. This results in a texture which varies smoothly and can be downsampled without producing artifacts in the lighting or albedo map offsets. The alpha channel of the fin texture, which masks the hairs, is downfiltered using the usual filters. We have presented advances to the state-of-the-art in real-time fur rendering. These advances are designed to make the fur more user-customizable at both author time and at runtime. Our extensions to previous techniques have included shell and fin extrusion using vertex shading hardware, per-pixel anisotropic lighting on fins and shells, hair color sourcing, hair density control, and bitmap generation.